There are two things. One, as soon as it was discovered, I realized that if it were a solid object, it has to be with a diameter of 20 kilometers. That's twice as large as the asteroid that killed the dinosaurs, bigger than Manhattan Island. And the previous interstellar objects were on the scale of hundreds of meters, like Oumuamua or Borisov. And if you consider rocks, for every object that is 20 kilometers in diameter, there are hundreds of thousands of objects that are hundreds of meters. So we haven't seen hundreds of thousands of Oumuamua or Borisov before we saw this one. Mm-hmm. And so that was one thing that immediately alerted me. As soon as I heard, I estimated the size, and that's I wrote an essay about that the same morning. And then the second thing, is that there is not enough material, rocky material in the interstellar space to account for discovering a 20-kilometer size rock every few years. I mean, this Atlas survey continued for a few years, and there is just, you can't supply such a large mass in rocky material every few years. And that, when I say you can't, I mean by orders of magnitude, maybe a factor of 10,000 falling short of what's needed. And I actually submitted a paper for publication. On the 4th of July, I was on vacation with my wife, but felt I need to make this point because
that's 3 days after it was discovered, right?
Yeah, and the people who wrote the discovery paper did not recognize that. They estimated the size, diameter 20 kilometers. They estimated how many such objects should exist so that we discover one every few years, and they just didn't put the two together. So I wrote immediately a comment on this, and they then revised their paper. My paper appeared, a week after the discovery. But now, of course, they claim to make the same point, but it was my point. And then, moreover, so what I concluded is if it's natural, it has to be much smaller than 20 kilometers. I calculated in my paper that it needs to be less than a kilometer in diameter, which then would be consistent with the mass budget or the reservoir in rocks in interstellar space. Mm-hmm. And in that case, you need a cloud of dust to reflect the sunlight and make it so bright, and a much more extended cloud of dust. And, that could be a comet. So I basically made this point. But then after that, I realized in collaboration with two colleagues, Adam Hibbert and Adam Crowell, that in fact there is something strange about the trajectory of this object. So this is the second thing that is unusual.
So just to reiterate your first point. So basically, to have an object that big, we would have need to see like an enormous amount of smaller objects. Is that what you said?
Right.
Because of its size, it's completely out of the regular.
Out of proportion. Out of proportion, yeah. Because we detected smaller objects. It's not as if you can say, you can't see the smaller ones. No, we detected the smaller one, Oumuamua and Borisov, and you just, you should see many of those. I'm talking about 100,000 of those before you see one that is that big. But the second issue is that there is not enough material in rocks in interstellar space to account for getting such a big object every few years. There is just not enough. By a factor of 10,000. I'm not talking a factor of 2 or something.
Yeah.
But then I realized that the trajectory of this object is very unusual, and decided. So the first paper that I submitted, I said, well, one way to reconcile it, if it's not a comet, is to say that it's targeting the inner solar system, that it's not on a random orbit, but it actually wants to visit the inner solar system. And my point was that it could be technological. In that case, if you find a big object, it has nothing to do with the mass budget. This object wanted to visit the inner solar system. Okay, so it has nothing to do with the amount of material in rocks.
Could it be coincidence, though?
No, not if the object is 20 kilometers. There is not enough mass to account for such things. So you need to target the inner solar system. So in the concluding sentence of my short paper, I said, the other possibility, if it turns out to be 20 kilometers in diameter, a rock is, or a solid object, then it had to target the inner solar system. It could be technological. And the editor of the research notes of the American Astronomical Society, his name is Chris Lintott, he said, no, you remove this. I will not accept your paper unless you remove this last sentence. Okay. And that, I regard that as inappropriate, unprofessional. Who is he to tell me how to, this is a valid possible interpretation? But at any event, he's in he has the authority to reject my paper. So I took out this sentence. But then I decided to write a full paper in collaboration with these two other collaborators on the technological possibility, because I don't like when people censor me. That's not the correct practice. I mean, science is about asking questions and then seeking evidence to answer them.
Yeah.
It's not about an editor telling me, don't ask this question, how dare you, this is ridiculous. And he spoke actually afterwards with the New York Post and said that derogatory things about this, the possibility of technological. He said that this is nonsense on stilts, and it should not be considered because it distracts from the good work being done on this object.
Mm-hmm.
That is completely ridiculous. What?
Yeah, Avi, quickly, do you have anything on the brightness as well? I think I've
what I said. That's what I said about the brightness. The brightness is telling you how big the object is because it comes from reflection of sunlight. So that was already the point we discussed.
Yeah.
But now coming to the trajectory, that's the second point. So
but there's no hint. Sorry, there's no hint that this can be artificial light coming from it's all reflection. You think?
Oh no, that's not clear. We see a certain amount of light, and when people took the spectrum of this light, they couldn't find any evidence for atoms or molecules that make up a cometary cloud around the comets. They did not find the evidence for that. All they found is reddening. The object is red. So if it reflects sunlight, it reflects red light more than blue light. Okay. So and that actually doesn't. So the simplest interpretation would be to say, okay, there is a dust cloud and the dust is red. But actually, the objects that we find in the Kuiper belt, which are about 100 at a distance of 100 times the Earth's separation, they have solid surfaces, the icy objects that are red, because they produce organic molecules on the surface from the impact of cosmic rays and ultraviolet light. So the red color is not telling us necessarily that we are talking about dust, a dust cloud. It could be a surface of an object. So from the spectrum, we don't know what is reflecting the sunlight with a red emphasis. But regarding the trajectory, so it looks like it's in the plane of the orbit of the Earth and the planets around the Sun to within 5 degrees. Mm-hmm. And the chance of that happening at random is 0.2%.
Oh, wow.
And then it comes to the Sun. On October 29th, it will arrive closest to the Sun. And when it arrives, the Earth would be on the opposite side of the Sun, so we will not be able to observe it. Mm-hmm. And this is the point in time when you can do what is called an Oberth maneuver. We do that with spacecraft. And
to slow it down, right?
So it could slow itself down significantly at that point. We won't see it, and then it could in principle get bound to the Sun and visit us. And also, if it doesn't slow down, it passes very close to Jupiter, Mars, and Venus. And we took the trajectory and just asked, okay, if you vary the arrival time randomly, if you allow arbitrary arrival time, you find that only with a probability of 1 in 20,000, you get it to pass so close to the inner planets.
Okay.
So it's as if you design the trajectory such that it will pass very close to, Jupiter, Mars, and Venus. It will arrive closest to the sun when we cannot observe it.
Mm-hmm.
And also it arrives closest to the sun in the opposite direction to the motion of the Earth around the sun. So it's called retrograde orbit. So it's moving relative to the Earth at that point at about 100 kilometers per second. And that is more than 3 times the fastest rockets that we ever launched. No way for us to intercept it. That's my point.
Okay. Just quickly to the velocity. Is that something unusual? These 69 kilometers per second. Is that fast, slow in cosmic terms?
No, I mean that's twice the speed of the Earth around the sun. It's relatively fast. The stars in the vicinity of the sun, the stars are moving at about half that speed. Mm-hmm. Mm-hmm. So it's substantial. But it doesn't tell you if it's artificial or natural. It's the kind of speed that you can achieve with chemical propulsion or engines that are more advanced than we use. In principle, you can do that. So it doesn't say much about this. Now, the other thing is that it comes from the direction of the Milky Way center, the center of the Milky Way galaxy, where that region of the sky is very crowded with stars. So that makes it very difficult for us to discover it on the background of a lot of stars in that direction. And so that's another. So all of these ingredients, if you had to design a trajectory with a purpose, it looks like these are very unusual properties. But if the object ends up being a comet, if we detect that within a month or 2, when it comes closer to the sun and it gets heated up, if we see that it behaves just like a comet, then it is a comet with a very unusual trajectory. That could be.
Okay. Well, what theory are you favoring? I mean, you're laying out the case, of course, for a more technological version of things.
Well, I can just give you a scenario. It's not a matter of taste. It's a question of what this object is. And if, for example, when it gets close to the sun, after that it doesn't come from the other side of the sun the way we expect, then the stock market will crash. Yeah. And there will be a question of what to do. And in one of my essays, I talk about the fact that we need to establish a new scale similar to the Richter scale in the context of earthquakes that gives us the risk from interstellar objects. People talk a lot about existential risks from artificial intelligence, from global climate change, or from asteroids, but nobody talks about the alien tech. And that is something we must contemplate now that we are detecting these interstellar objects. We need to check each and every one of them, whether they might be technological. And if it looks like a comet, we give it a 0 on this scale. And if it looks if it maneuvers with propulsion, as if it has an engine, we give it a 10. And there needs to be an organization that decides how to make policy internationally, how to respond to such a high-risk encounter. You
mentioned before, when it comes closer, there's a chance for us to look at it, I think, to train the Hubble telescope on it. To what certainty of degree would we know what it is by this point, if we really have all these assets focusing on this thing?
Yeah, I think within a month or 2, as it comes much closer to the sun, if it is a comet, it must erupt in ways that are very similar to the comets that we are familiar with. There would be a big glow of gas and dust around it, and it will be clear. And the Webb telescope can measure the composition of the cometary cloud around it. And
I meant the Webb telescope, sorry.
The Webb telescope.
Yeah, I meant that.
Because we have a lot of time, we could also look at it in December once, it will, the Earth will be closest to it, because the Earth is on the other side of the sun when it comes closest to the sun. So we have until, throughout this calendar year, we have an opportunity to get a lot of data. And one reason I wrote this paper about the technological origin, a potential is to encourage my colleagues, observers, to get as much data as possible. I'm worried about not having enough data more than I'm worried about, this interpretation being wrong.
Last quick question: these interstellar objects. I mean, how now this is like the third within a couple of years. How usual or unusual are they? What are we learning about them?
So actually, now we have a new era with the Rubin Observatory in Chile, which actually was inaugurated last month in June. And the Atlas telescope that discovered this object is 0.5 meter in size. The Rubin Observatory is 8.4 meters in diameter, that telescope.
Okay.
And actually, the Rubin Observatory, they could go back in time before it was discovered by Atlas. They could see this object. So with the Rubin Observatory, every few months, we expect to find an interstellar object. So altogether, maybe 50 over the next decade. So that means that, we will have several of them every year. We'll have to, instead of giving them a special name like Oumuamua, Borisov, Atlas, we will have to give them a name that is related to the date they were discovered. There will be many every year, and all of them will come from the Rubin most of them will come from the Rubin Observatory. So it's a new era, and that's why I'm saying we should check each and every one of them, whether they are a rock, icy rock, or something else.
Okay, wow, this is very, very, very exciting indeed. So if we see a tail, then it's probably a comet. If it never shows up from behind the sun, then we should start panicking, right? So that's pretty much what it is.
My recommendation is if you are planning an annual retreat or vacation, do it before October 29th.
To be sure.
Just to be on the safe side. Yeah. I already received a text message from a fan that said to me that he already traded options against the volatility of the market, and they will expire on the 29th of October.
Oh wow! Okay, so that's. But we can't see it from Earth, though, right? I read it's because it's behind the sun when it's close.
Yeah.
Or is it when it comes back?
We cannot see it during October when it goes within 30 degrees of the sun because it's too bright.
Yeah.
But before October 1st and after October 31st, in November, we should be able to continue to see it.
Yeah, and there's also, I heard it's also very close to Mars, and some of the hardware could capture it as well.
Yeah, Mars and also potentially even Jupiter. Yes.
Yeah, I mean this satellites that's going around Mars. Could they see it when it goes by?
Yeah, they could see it, but they don't have big telescopes.
Oh, okay.
So one possibility is to give them a boost if they can fire the rocket. The engine that they have. If they can fire it and get closer to it, that would be good. But you have to understand that these cameras that they are equipped with, are usually of a few centimeters, maybe 10 centimeters aperture. They're not very big.
Yeah.
Compared to the telescopes we have on Earth that go up to 10 meters. And therefore, even though they are closer to it than the Earth is, the quality of the images will be worse than the ones we have from Earth. But when we can't look at it, like, when it goes behind the sun for us, that's when the other telescopes can help.
Mm-hmm. So we will be able to probably figure it out, right?
But I should also say that if it's a comet, it could completely disintegrate. If it comes close to the sun, gets warmed up, we could see fireworks and it will disappear after that. That's also possible for comets. They sometimes are very fragile.
So they don't make it around the sun, more or less.
Yeah. But of course it will raise the suspicion, where is it,
Oh, that's the worst case. Okay. So where is it? Panic, but it's still a comet, right? Okay, never mind.
No, because it could be. One can imagine it being a mothership that sends probes, mini probes to the planets, and I'm also leading the Galileo project, and we are now building 2 additional observatories, one in Pennsylvania, another one in Nevada, that will monitor for objects that are outliers, that are not human-made, inside the Earth atmosphere. And of course, if we see a lot of activity after the passage of 3I Atlas, then that would be very suspicious.
Oh, wow. That all sounds a little bit like Independence Day.
My point is that our imagination is very limited because it's dictated by what we've witnessed here on Earth. And when you have a blind date with someone from another star, all bets are off.
Blind date from another star. That's a good one. All right. Okay. It's exciting times. Thank you so much for your comments, and I will send you the link when it's published.
Okay, my pleasure. And you can access if you need photographs, you can access my website.
Okay, fantastic. All right. Okay. Thanks a lot, Avi.
Okay.
Have a great day.
Bye bye.
Okay. Bye.
Bye bye.